Hello everyone, welcome again to this series of interviews by Shapelets. I'm Fatima Ramos, and today I'm pleased to introduce you to Adrián Carrio, who is a lead data scientist at Shapelets. Adrián has also co-founded ThermoHuman and Dronomy, and he's the author of more than 30 scientific publications and one patent. So today we'll discuss the background, the roles, the difficulties, and the key challenges of day-to-day operations of data scientists. Hello, Adrián, welcome, and let's start.
I studied industrial engineering in the University of Oviedo in Spain and worked there as a research scholar for like a year, working on computer vision applied to the steel industry. Then in 2013, I moved to Madrid to pursue a PhD in automation and robotics. And this was a very fruitful period. I had the opportunity to learn a lot during my PhD and to apply AI to several tech transfer projects in various industries. Also during this period, I co-founded ThermoHuman, which applies AI to thermography in order to predict injuries in sports. And I also worked as CTO for the Spanish fintech company Accurate Quant. And then in 2021, I joined Shapelets. Data science is quite a powerful set of tools in the sense that it renders the invisible visible. I personally like it very much because it exemplifies very well how the scientific method works. We typically have observations of something we know little about, and it may be how the way an industrial process evolves, or the way people's opinions are affected by certain events, or the way the human body operates at a very low level. We then hypothesize by building all these models, and finally we check if our hypotheses are statistically relevant. So the only thing that modern data science adds to all of this are visualization techniques that help present and understand all these insights that we discover. Create impacts in very heterogeneous sectors. Data science is very interdisciplinary, and I'm a curious mind, so I really like to dig into many different problems, like e-health or energy, manufacturing industries, marketing. Anything is possible with data science. Well, I do not really have a role model, and to be honest, I do not follow that many other data scientists for the work, but rather academic profiles that I consider relevant. There are many of these, of course, and each of them are applying data science to specific fields. But if I had to mention a few, it would probably be the fathers of AI. Geoffrey Hinton, Joshua Bengio, Jan LeCun, and also Ian Goodfellow. So my advice is to keep things simple. Many of us data scientists, because we're techies, we tend to overcomplicate things, and we try to use more complex or sophisticated models. And this is usually the opposite of what one is supposed to do. So as Occam's razor states, the simplest explanation is usually the most probable. And another piece of advice would always be to try to split large analysis problems into smaller ones. Start from the easiest approach in order to test and build your baseline. And then increase the complexity gradually, controlling it, and that way you avoid the complexity of the problem controlling. You control it. One of the biggest challenges for a data scientist who is presented with a new problem is to find high quality relevant data. In many cases, however, the data is already given, and you're required to get a proper understanding of the problem you're trying to solve. This is usually an important challenge, and acquiring this domain relevant knowledge is usually especially challenging if you're not familiar with the specific industry you're solving the problem for. The features I value the most are the ones that prevent me from wasting time or doing low value tasks. So for example, fixing format issues is something that I personally hate to do. So if I come across a tool that prevents me from doing those type of tasks, that's great. I also appreciate a lot low code libraries that bring large functionalities with a few lines of code. And I also love, all kinds of visualization tools that let you do things that are not easy to do with most common tools and that are highly customizable. These are really nice tools to use. For me, the main issues are related to communication. Since you have built your solution using a data scientist mindset, it is sometimes hard to explain what you're doing and how you have arrived at the results without sounding too technical. So communicating I think is especially important if you're using some black box-like models. And in this case, you usually have to make an extra effort for the stakeholder to actually understand what you're doing and actually to believe in the results. In general, you have to be able to put yourself in the eyes of the stakeholders and try to see the problem through their eyes. We want to use the same jargon that they use and provide the results using the same units, the same metrics, if you want them to respect the work you're doing. First, I probably want to get a proper understanding of the problem with the stakeholders. So you want to try to understand things at the lowest possible level and learn about the data sources, data relationships, and the systems and sensors that are behind them. Then you look at the data and you check for some obvious insights, missing data, and you also have to pay special attention to dataset imbalance, which is extremely common issue in data science. And then comes the model building stage, where you want to test a bunch of simple models and make sure they don't overfeed. And if you have a lot of data, you can use a more complex model, but it's basically checking for different models and evaluating them. And once you arrive to the right model, you can simply build the visualizations to make your insights really easy to grasp. That would be my approach to follow. Okay, well, with respect to the skills, in my opinion, I think data scientists should have a very strong mathematical background in statistics and linear algebra, and being familiar with things like significant tests and this type of techniques. Of course, programming skills in Python and being fluent with libraries like pandas and NumPy, and also if possible have some sort of familiarity with machine learning libraries such as scikit-learn, TensorFlow, PyTorch. Then it's also very important to be very familiar with visualization libraries like Matplotlib, Plotly, Altair, or utils like Microsoft Power BI. And you also want to know how to use Excel. It might seem funny, but Excel can still be quite useful for quick checks in your data. And I think one of the most relevant skills is communication. So having proper communication skills and being able to explain complex concepts without being too much technical. That would be my set of skills.
Well, that's it. I'm going to close out this session. Thank you, Adrián, for sharing your experience with us. And we will see you soon. And thank you, everyone, for listening.
Thank you for having me. Bye.